Hello, in this session we'll go with potassium permanganate KMnO4 where manganese oxidation state is +7. +7 is the highest oxidation state of manganese, so from there it will come down. It can come to +2, it can come to +4, it can come to +6. So in all these kind of cases it is going to function like an oxidizing agent. Potassium permanganate is a very good oxidizing agent. When we were discussing organic chemistry, alkenes and alkynes cases, potassium permanganate Bayer's reagent to use. Bayer's reagent is called alkaline KMnO4. Okay, dilute KMnO4 in basic medium. That is Bayer's reagent, where potassium permanganate color, purple color, or is a pink color, violet color you can say. This violet color will be decolorized by the unsaturated compounds. So it is going to be a test for alkenes and alkynes. For the remaining aldehydes and ketones, otherwise you go for any, even alkenes also you take. If you are taking KMnO4, hot conditions, very strong oxidizing agent, it can cleave the carbon-carbon double bond also. It can oxidize the remaining compounds like alcohols into acids, aldehydes into acids. So it's a very good oxidizing agent. One very special reaction I think you remember, tertiary alkanes. Primary, secondary alkanes, there is no reaction, but tertiary alkanes, when react with KMnO4, they turn into tertiary alcohol, tertiary alkane to tertiary alcohol. You can remember this point. Okay, let's come to the D block elements now. Now we'll go with our regular D block element topic, that is KMnO4. These are lengthy equations, that's why I have already written. Remaining I will explain you here. Potassium permanganate. Potassium manganate, potassium permanganate both are there. Potassium permanganate is violet color, potassium manganate is green color. Potassium manganate is paramagnetic, potassium permanganate is diamagnetic. You can remember this point also. Then how it is prepared. The methods of preparation of KMnO4. Only one method generally we use, that is MnO2, manganese dioxide, that is fused with potassium hydroxide, then oxidized by using HNO3 type oxidation. O2 we are using here. It forms K2MnO4. K2MnO4 is potassium manganate. MnO2 gives you potassium manganate when it is fused with base like potassium hydroxide, sodium hydroxide, and treating with HNO3, which is an oxidizing agent. So I am writing here O2, that means that is coming from the acid. Then whatever the manganate is found, this manganate in acid medium undergoes disproportionation. Disproportionation, we know one atom only undergoing both oxidation as well as reduction in the same reaction. You can see here MnO4 minus 2, the oxidation state of manganese is +6. The oxidation state of manganese in permanganate is +7, whereas here it is going to be +4. Increase, decrease, both are happening in the same reaction. So you can call this is a disproportionation. MnO4 minus 2 undergoes disproportionation in acid medium to form potassium permanganate. This is the method of preparation potassium permanganate. One more you can see, that is commercial method. Commercial method also same thing. MnO2 fused with KOH, acidified with HNO3, MnO4 minus 2. So first step is same. MnO4 minus 2 is nothing but K2MnO4, that is potassium manganate. Next, electrolytic oxidation. Okay, now here we mentioned that this is oxidized disproportionation reaction in acidic medium. We are doing an electrolytic oxidation in basic medium, so that turns into MnO4 minus. Potassium permanganate is found. MnO2, MnO4 minus 2, first step is same. Okay, now fused with KOH and oxidized with HNO3 to form MnO4 minus 2. MnO4 minus 2 is oxidized to get MnO4 minus, that is permanganate is found here. Laboratory method of preparation, you can prepare from manganese. Mn plus 2 is called manganese when you are taking manganese, and it is oxidized by using S2O8 minus 2. Okay, now S2O8 minus 2 is peroxodisulfuric acid, you can say. Okay, now so by using peroxodisulfuric acid, this is oxidized to MnO4 minus. MnO4 minus, that is potassium permanganate is formed. This is one laboratory method of preparation. And one very special property of KMnO4 is KMnO4 undergoes again a change to form K2MnO4 and MnO2. This is again disproportionation. KMnO4 +7 oxidation state, this is +6 oxidation state, it is +4 oxidation state. So it should not be called disproportionation, very sorry for that. KMnO4 is +7 beta, it is undergoing +6 and it is undergoing +4. So it is decomposed. On heating, KMnO4 decomposes to K2MnO4 as well as MnO2. Reverse, you can say comproportionation. Even not comproportionation. This reaction is not for disproportionation. and not for calm proportionation, because this oxidation state not intermediate to these two. So this cannot be considered. This cannot be considered under disproportionation or calm proportionation, just a decomposition reaction. This is about the potassium permanganate preparations. Potassium permanganate is prepared from MnO2. MnO2 is first fused with KOH, then oxidized by HNO3 to form manganate. Manganate is by electrolytic oxidation or by disproportionation using acidic medium, you can convert into MnO4 minus. In the laboratory, you can prepare from manganese by using S2O8 minus 2, that is, you can say peroxodisulfuric acid, salts or peroxodisulfuric acid you can use, that turns into SO4 minus 2. This is the regular method of preparation for the potassium permanganate. What is the specialty of potassium permanganate? Potassium permanganate, as I said, it is of violet color. Sorry. Potassium permanganate is violet in color. KMnO4. Its ionic form we write MnO4 minus. It is tetrahedral. It is diamagnetic. Tetrahedral and diamagnetic. You can see manganese. 1, 2, 3, 4. It is the structure of MnO4 minus. K2MnO4 also we have. K2MnO4 I write with green because it is in green color. MnO4 minus 2. It is also tetrahedral. This is in violet color. It's in green color. It is paramagnetic. Because of unpaired electron, it is paramagnetic. Unpaired electron, paramagnetic. Structure is going to be almost same. Mn, 2 oxygens with double bonds, 2 oxygens with single bonds, 2 minus charges. It's green in color, it's violet in color, both are tetrahedral, both are sp3 hybridized, but this is diamagnetic and this is paramagnetic. You know, KClO4 structure, KClO4 structure will be same. ClO4 minus will be having O minus, double bond O, double bond O, double bond O. So you can say this is isostructural with KClO4. KClO4 structure and KMnO4 structure both are same. You can see 3 double bonds, 1 single bond, 1 negative charge. 3 double bonds, 1 single bond, 1 negative charge. Very similar, isostructural with KClO4. You can have a look. And very special about its color, it is having a intense violet color. Very intense violet color you can see. Potassium permanganate. Then it's a temperature based paramagnetism. It is not very highly paramagnetic, but it is temperature based paramagnetism. This is little higher subject topic, not required for you at your NEET level or JEE level, but you can remember its paramagnetism is based on the temperature based paramagnetism. That means generally I said this is diamagnetic, but when you are changing the temperature, there is a possibility of getting paramagnetism also. Second thing is, you can remember, it is not having any unpaired electrons, even though it is showing color. The color is because of the charge transfer phenomena. We were discussing in D black elements, charge transfer phenomena in color property. Generally, colors are because of the DD transition. When unpaired electrons are there, they show colors. Even though MnO4 minus or Cr2O7 minus 2, they do not have any unpaired electrons, still they are showing color. That is because of the charge transfer phenomena. Charge transfer phenomena. This point you can note. It is not very much soluble, slightly soluble in water you can say, and color, solubility, all these properties are physical properties. Then very important lines are its nature. Okay, how it changes. MnO4 minus changes to Mn plus 2. It changes to MnO2. It changes to MnO4 minus 2. All are very special, very important also. Why? Because in the first case, the change in oxidation state is from plus 7 to plus 2. The change is 5 electrons. Here change is from plus 7 to plus 4. The change in oxidation state is 3. So 3 electrons. Here the change in oxidation state is +7 to +6, one electron is involved. So these are the direct questions. They will ask you direct questions. In acidic medium, this happens in acidic medium, this happens in neutral medium, and this happens in basic medium. MnO2, MnO4 minus 2, Mn plus 2. In acidic medium, MnO4 changes to Mn plus 2. In neutral medium, changes to MnO2, and in basic medium, changes to MnO4 minus 2. Okay, so these are very, very special. About these, you need to remember the E naught values also. E naught values are all are positive values. SRP values, you can say standard reduction potential values. SRP values of these are, when it is changes to Mn plus 2, it is 1.52. MnO4 minus 2, Mn plus 2 is 1.52. And when it changes to MnO2, here it is highest 1.69. 1.69 voltage. And when it changes to MnO4 minus 2, this is the lowest of all these, 0.56. There is no need to remember. Don't by heart. Just you see. When it changes MnO4 minus MnO2, it is going to be 1.69. From these, you can see all are having greater value. Okay, now. So plus 1.52, plus 1.69, plus 0.56, all are having positive SRP values. When they are having positive SRP values, when they are above H plus in the electrochemical series with the positive values, then these must oxidize water. Water should be oxidized by KMnO4. Practically, it should happen. And if you see, actually what happens is, it is to, but the reaction is going to be very, very slow. If you are adding MnO4 minus and you are expecting water to be oxidized, that reaction is very, very, very slowly happening. That means you can say here kinetics as well as feasibility. The feasibility is definitely there because of its E naught value, but the reaction kinetics is going to be very, very small, very, very slow. If you want to make the oxidation of water by MnO4 fast, that must be added with Mn plus 2, and temperature is also to be raised. If you are increasing the temperature, and if you are adding Mn plus 2 ions, manganese ions, then the reaction is going to be fast. Then you can say. That means sometimes the reaction looks, it is possible, but again, kinetics are also going to be very, very important factor. MnO4 minus oxidation of water, kinetics are going to be very, very slow. If you want to make this reaction fast, you need to use their Mn plus 2 ions as catalyst, and temperature is also mandatory for that reaction. Then, what is the nature of MnO4 minus? How it functions in oxidation and all these reactions? Let us see. MnO4 minus oxidizes C2O4 minus 2. C2O4 minus 2 is nothing but oxalate. Oxalate is oxidized to carbon dioxide. Okay, all these reactions I am taking in acidic medium. In acid medium, C2O4 minus 2 is oxidized to carbon dioxide. How you can say? Oxidation state of carbon is here +3. Here oxidation state is +4. So definitely it is oxidation. SO3 minus 2, sulfite, oxidized to sulfate, SO4 minus 2. Sulfur oxidation state +4, sulfur oxidation state +6. Increase in oxidation number is oxidation. NO2 minus, nitrite, oxidized to NO3 minus, oxidation state +3 to +5. Increase. I minus is oxidized to I2, oxidation number -1 to 0. Increase. Oxidation. Okay. So all these are the oxidation reactions. Along with these, it can oxidize even H2S. H2S is oxidized to sulfur. Oxidation state of sulfur is -2 here. Here it is going to be 0. -2 to 0, that is again oxidation. So in all these cases, you can use even iron. Fe plus 2 is oxidized to Fe plus 3. Ferrous to ferric, nitrites to nitrates, sulfites to sulfate, oxalate to carbon dioxide, I minus to I2, H2S to sulfur. These are few examples. Okay. And KMnO4 specialty is KMnO4 itself undergoes a change when it is added with Mn plus 2. MnO4 minus when treated with Mn plus 2, it changes to MnO2. Very, very special reaction. In acid medium, when potassium permanganate is treated with Mn plus 2, in acid medium, it changes to MnO2. Okay. Till that time I was explaining you this one. Here oxidation state of manganese is going to be Mn. Here it is minus 2 to 0 I mentioned. This is plus 7, this is plus 2, this is plus 4. Can we call now as calm proportionation reaction? Okay, I wanted to explain this one there. Calm proportionation. Two different oxidation states are combining to give you one oxidation state. MnO4 minus reacts with Mn plus 2 to give you a calm proportionation reaction to get MnO2. So all these are oxidation reactions in acidic medium. C2O4 minus 2 to CO2, SO3 minus 2 to SO4 minus 2, nitrites to nitrates, iodides to iodine, H2S to sulfur, Fe plus 2 to Fe plus 3, and MnO4 minus E reacts with Mn plus 2 in acid medium to form MnO2. Okay, here you can say Mn plus 2 is oxidized to Mn plus 4. Okay, this is again oxidation only. So all these are oxidation properties. Along with this, we have generally oxidation properties in basic medium. All these are in acidic medium. And one important point is, this should not be forgotten. Acidic medium means you need to use your H2SO4 as medium. Don't use HCl. This is one very, very important question. In KMnO4, oxidation reactions, whenever you are writing, for example, this reaction if you are writing, we write 2 KMnO4 plus 5 H2C2O4 plus 3 H2SO4. 3 H2SO4 only we write there. We don't write HCl. H2SO4 is used as medium, not HCl. HCl cannot be used as the medium in that reaction because the reason is very interesting. KMnO4 even oxidizes Cl minus to Cl2. HCl is oxidized to Cl2 by KMnO4. Potassium permanganate is a very good oxidizing agent. It oxidizes HCl to Cl2. What about sulfate then? Sulfate is already in the highest oxidation state form, so it cannot be oxidized. If it is sulfite, then sulfate is oxidized to sulfate. It's already sulfate, so there is no worry. So whenever acid medium is there for potassium permanganate, you need to use there only H2SO4, not HCl. One very interesting point it is. So all these are oxidizing properties. Potassium permanganate is only oxidizing agent. It cannot function like any other agent, only oxidizing agent, but in acid medium as well as basic medium. The basic medium very specialty is I minus. If you are taking acid medium, it is giving you I2. If you are using basic medium, this will be converted to IO3 minus. Remember, this is very, very important. So when such kind of changes are there in entrance examination, they will become like questions. So I minus when treated with potassium permanganate in acid medium turns I2. In basic medium, that will be turning into IO3 minus. IO3 minus. That is one special. And in basic medium, S2O3 minus to thiosulfate is oxidized to sulfate. It is also oxidation only, but this is again basic medium. I was giving you maximum oxidation reactions and basic medium reactions, but all these are oxidation reactions. In all these kind of cases, potassium permanganate is oxidizing the compounds in these kind of ways. So any of these can turn into a question. Okay, any line can be converted into a question. So you must be very, very careful about all this. Potassium permanganate is a very good oxidizing agent in organic chemistry reactions, and it's a very good bleaching agent also. It's a bleaching agent for wool, silk and cotton. For all this, it's function like a bleaching agent, very good oxidizing agent. Structure point of view important, potassium permanganate, potassium manganate. Color point of view important. That's it for potassium permanganate. In next session, we will meet up with potassium dichromate.